chapter 7 is the most important chapter really this year. It's where all our calculation pieces are coming from. Okay? There's also, this is where we learn to name and write chemical formulas. Seems like two completely different things, and they are two completely different things. I don't know why they threw both of them into the same chapter. So I typically break chapter 7 into two pieces. Okay? There's going to be the naming and writing formula piece. There's going to be the calculation piece, the quantitative piece. This year, I'm going to do both at the same time. Meaning, we'll work on some calculation things, and we'll work on some naming and writing formulas things. We'll just keep going back and forth on that. We'll bounce back and forth. The calculation piece is all going to be in your own notes. The naming and writing formulas, I've got a little packet that I give you guys that has all the rules for everything. So you can always go back to those and see the rules. That way you guys don't have to spend 5 days writing down all the things that I write down on the board. That doesn't make any sense. No, it doesn't. You ever be making the joke? Do you ever remember me making the joke about the kid? Freshman asks the question, do I have to?
Oh, yeah.
Do I have to erase everything I wrote down? Mm-hmm. Yeah, this would have been that stuff. All the rules for naming and writing the formulas. So anyway, here we go. I'm going to throw a word at you. It'll be the first time you've seen the word. Let me put part 1 up here. But like I said, we're going to do part 1 and part 2 simultaneously. Compositional is not the word that I'm throwing at you. I'm assuming you've heard of the word composition anyway. Here's the word. Stoichiometry. Have you heard of this word? No. Okay, good. When you say to other students, hey, what are you guys doing in chemistry? You say, oh, we're doing stoichiometry right now. Many of them in the past that have had chemistry in the past, oh, I hated that. Well, stoichiometry, there's 2 different variations of it. One of them is compositional, that's what we're going to be doing. The other one's reaction stoichiometry. The one that they get their pennies in a bunch about is reaction stoichiometry. We'll get to that probably either right before or right after Christmas break, depending on how things go here. Anyway, all stoichiometry refers to is the mass relationships amongst various substances. When we're doing compositional stoichiometry, it's within the atoms that are in a compound. When we do reaction stoichiometry, it's going to be the compounds within a chemical reaction. Okay? So this is not that big of a deal. But it is incredibly, incredibly important. This is, to put it in words that you guys are familiar with, mole conversions again. Except now, instead of just doing with individual atoms, we're going to be doing it with compounds. So you'll need your periodic table. And actually, I'm going to start off with the bonus questions that were on the test. Did anyone do either of the bonus questions that were on the test? Let me see if I can find those. Don't write this next thing down, okay? But what if I ask you, I'm going to write this down. You already have this. You can write it down if you want, but you don't have to. You already have it. Now, here's where it gets different. How is this different? Yes? It used to say what? No. Said atomic, average atomic mass. You guys remember that? Because up until this point, we were only dealing with atoms, or one element at a time, right? Now we're going to be dealing with compounds. Okay? And so that's why I put these two words up here. Technically, if you really want to be very technical about this, the phrase formula mass would refer to ionic compounds. The word molar mass would refer to covalent compounds. You know what though, in just chemistry, everyday chemistry, both of those are used fairly interchangeably. I showed both of them to you so you guys don't get your panties in a bunch when you run into them, okay? It all refers to the same thing. You'll see gram formula mass, you'll see molecular weight. Let me throw that one out there because you're going to see that one a lot. It just depends on the source that you're looking at and how old that source is, and it really, there's a lot of factors, okay? All those mean the same thing, okay? Now, since we're going to be doing mole conversions with these, obviously, we need to learn to calculate these. And there's what one of the bonus questions on the test was. One of them was, one version had this, and the other version had probably magnesium aluminum carbonate. Did anyone attempt either one of those? Does anyone remember? Drake did, you did, a couple of you did? Okay. In my opinion, probably the easier of the two. Okay, required less work, but not everybody had different. That's why I gave you two options there, I think, for the bonus. Okay. Now, on the quiz, on the mole conversion quiz, I gave you a very similar question, and a lot of you tried it and/or got it right. Anybody get 17 or over on that quiz? Yeah. So in order to get over, you had to try that, right? And I really only accepted a yes or no. I didn't give partial credit on it. You got it right or you didn't get it right because it was bonus. Okay. Those were a little bit easier. I think they were things like calcium carbonate or something like that. Does anyone vaguely remember that? Okay. It's the same idea. Since we have 1 mole of this, okay, we have 1 mole of this substance here. Let me put it this way. I think I have one in here. I do. Okay. This is a box. I have 1 box of markers. This isn't as good of an idea as I'd like to do. Here is a container. We'll call this a container. We have a container of markers. You guys see that, right? Within that 1 container of markers, not everybody's going to be able to see this. How many red markers are there? 2. How many blue markers? 2. Yeah, 2. There's light blue, dark blue. Don't get too upset about that. How many brown markers? There's 2. How many orange markers? 1. Okay, so within 1 box, I can get different numbers of things. Where I'm going with that is, oops, in 1 mole of this, how many moles of calcium are there? 3. How many moles of phosphorus? 4. Phosphorus. Okay. Why did I write this formula that way? Well, don't write this down, but here's another way I could have written the formula. Or here's another way I could have written the formula. Oh, that's it. Which would you prefer? This, or that? Anybody for the top one? Right. A lot easier to write, isn't it? Okay. Now you guys recognize PO4, I hope. What's PO4? Phosphate. Very good. Would you recognize this as phosphate? Would you recognize, well, yeah, you'd recognize these as phosphates, but how many are there? 2 of them, right? And there's 3 calciums. So why do I write this? Why do I write it this way? Come on in. It's a shorthand way of representing these. See where I'm going with that? So now, what do you do with that 2? Well, it's just like math class. What do you do with that 2? Distribute through. What are we going to do with this 2? Distribute through the parentheses. Okay? So, I'll ask once again, how many phosphorus atoms? How many moles of phosphorus? 2. And how many moles of oxygen? 8. Because when you distribute, you multiply, right? Because there's one mistake, small mistake that I'll still see students early on make is they'll add the 2 and 4 and come up with 6. You distribute, you multiply through. So, anyway. With that being said, there are 2 moles of phosphorus, and how many moles of oxygen did we say? 8. Okay, so if I want to find the mass of 1 mole of this stuff, I know that there's 3 moles of this, 2 moles of this, and 8 moles of this. Do we know how to find the mass of the moles of individual elements? Yeah, we did that fairly easily, right? So, calcium, as you guys know, atomic mass is, okay, as you can look up on your periodic table, 40.08, very good. Phosphorus, as you know, or we can look up, is 30.97, and oxygen is 16.00. So we just multiply across, get 120.24. We get, 61.94. Somebody can check my math on that. And have I mentioned to you guys that you need to know your multiples of 16 pretty well? This is why. 128. Okay, and we just add all those up. Pretty straightforward little process. You can use your calculators. I'm just doing it because I don't have a calculator. So we'll go 8, 1, 10, 11. So I got 310.18 grams per mole. Someone has a calculator or want to check my work, I highly recommend that. Here's your chance to tell the teacher that he's wrong. Please take advantage of that opportunity. Okay, let me tell you where this is going. Ultimately, I'm going to walk through 2 or 3 of these with you, but then I'm going to cut you loose and you're going to do it. So you might have your calculators out anyway. Thank you. All right. Let's move over to the other one. The name of this one, by the way, is calcium phosphate. You don't necessarily need to know that yet. We'll go over that later. Does anyone want to take a stab as to what the name of this one might be? What's that? It is a carbonate, but the whole thing. That's it. Aluminum carbonate. There, you just learned how to name a ionic compound. How'd that go? All right. So, same question. What is the mass of 1 mole of aluminum carbonate? By the way, do you see what unit I provided down here? Grams per mole. Molar masses Formula masses, molecular weights, their unit is grams per mole. The reason I emphasize that is a lot of students forget the per mole part later in the year when it matters. Don't forget the per mole part. All right, moving on. So, how many moles of aluminum are in 1 mole of this? 2. How many moles of carbon? 3, because that 3 distributes, right? So 3 moles of carbon. And how many moles of oxygen? 9. See, this is easy. Remember I told you guys, when things are easy, don't make them hard. Okay? What's the mass of 1 mole of aluminum? 26.98. And I should technically put grams per mole there. Carbon, as we all know, is 12.01. And oxygen, 16. Oh, 53.96. And 144. I think.
Yeah.
Add all those babies up. All right, 233.99. How hard is this? It's not very hard. It's not intended to be very hard. I've actually given you some of the more complicated ones that you're going to run into. Not the most, but getting close. Getting close. Okay, so if you understood this and can get this, you're going to be good to go on this. And we'll be ready to move on. So, let me give you a few to try and learn. Oh, let's go with and once again, we're determining the mass of 1 mole of each of these compounds. Or in other words, we're finding the formula of mass or molar mass, depending on what the substance is. I'm going to give you 4. They're going to get progressively more interesting. I need a fun compound. Okay, here we go. lastly, okay, try those 4 on your own. I'll wait a little bit of time and then write the correct answers up for each of them after you've had a chance to try. Anyone not done with the first one yet? get all 4 correct?
Except for like, I just added.
Did you get it figured out?
Yeah.
You figured out what went wrong?
Yeah.
What because I just did mine on my calculator real quick. So can you verify my answers? Or not?
Yeah, I did.
Okay.
I just,
Anyone else, can you verify mine? You're good? You got those?
Well, I don't know if this is like a big deal or anything, but, for the second one, I don't understand how you got 46.08 because like the whole thing completely out was 46.068.
Ah, but here's the thing. You remember a long time ago I said to you guys, round everything, all your atomic masses to the hundredths place. And if we round all our atomic masses to the hundredths place, if you have a periodic table, that means because of the addition thing, that means all of our molar masses are going to be to the hundredths place. We don't have to worry about that addition and subtraction rule.
But how did you get 8 instead of 7 then?
Well, carbon's 12.01. There's 2 of them.
Okay.
There's 6 hydrogens, 1.01. So that's 8.01s. I'll do it for you. So we have 2 carbons, right? 24.02. We have 6 hydrogens. And we have a oxygen. Eight, 0, 16.
Oh, I see what I did.
Okay.
I did the 5 hydrogen and then I did another.
Doesn't matter if you did 5 times 0.101 and plus 1.01, you still get 6 101s. You just did something weird.
Yeah, apparently.
Okay. Who else? Was there anything else of concern? Well, I'm going to guess that last one might have been a concern for some of you. How many got the first 3 correct? Not all of you. Any more questions? Okay, just for fun. How many magnesiums? How many moles of magnesium? 3. Here's where the fun starts. First of all, what is this ion? No. Well, and see now, is it ferricyanide or ferrocyanide? You currently probably don't have enough information to answer that question. That will come up later. But remember, ferricyanide has a 3 negative charge. Magnesium has a 2 positive charge, right? So you may remember this from physical science. The 2 comes down here, the 3 comes down there. So it is ferricyanide. But that's okay. You don't have to worry about that right now. But anyway, how many moles of iron? 2. How many moles of carbon? 12. Very good if you got that. And then obviously how many moles of nitrogen? 12. Okay. So if you got this one right, you have nothing to worry about on this piece right now. And even if you didn't get it right, you probably saw what happened there and you'll be able to get it right from now on. All right, where am I on time? How much?
10.
Ah, excellent. Enough time to come up with an assignment for you. No questions. Are you sure? All right. I'll just give you another 5 or 6. Oh, by the way, that second carbon-containing compound, what was it, C9H8O4, that was something called acetylsalicylic acid. You guys know it as aspirin. That was the formula for aspirin. All right, moving on. What do you think? 5 of them? 5 of them will be appropriate? Okay. Let's come up with some fun things. Yeah, that's not so fun. I don't even need those. See, these aren't even any fun. I don't know the formula for that. Let's do this. Where is mine? I don't know if I want to give this to you or not. And let's see, what else? What would be one? Yeah. Just for fun. All right, there's your assignment, those 5. Find the formula mass or molar mass of each of those. 2 of them are molar masses, 3 of them are formula masses. Doesn't matter. There's your assignment. Remember the rule? When things are easy, don't make them hard. Is this easy? Now tomorrow, we'll go the next step. We seem to be missing chance.